This is video 2 of our chapter 11-13 review for our test. So this is a multiple choice free response question from a previous AP exam. So we have elemental analysis of an unknown pure substance indicated that the percent composition of by mass is as follows. So the first thing we're going to do likely is find the empirical formula of this compound. That's exactly what they tell us in A, but then they give us a little bit of information about a freezing point determination experiment, which we'll have to use to determine probably the molar mass of it. So let's go ahead and take a look, if we could, at the part A. I'll go ahead and swing it up. So what we'll do is we'll take the masses of, or the percents of 3 of our elements and convert them into moles. So remember, empirical formula is mass to mole divided by small multiplied to the whole. So let's do this quick. So we have 49.02% or grams of carbon. We have 2.743% or grams of hydrogen. And we have 48.23% or grams of chlorine. So each one of these converted to moles is what the first step. So a mole of carbon is about 1201 grams. A mole of hydrogen is about 101 grams. And a mole of chlorine is about 3545 grams. So if we do this, for the first answer, if you plug this into your calculator, go and pause it and plug these in so you get the right answer. It should be 4081. Oh, apologize there. Slight delay there. And we're back to good. Maybe. There it is. So we got this many, this is moles of carbon now. And we have ourselves, for hydrogen, we should get ourselves 2.716 moles of hydrogen. And for chlorine, we should get 1.3605 moles of chlorine. The next step is dividing by small. So if we divide all these by the smallest, which is 1.3605, this becomes 1 mole of chlorine. This becomes, if we divide by 1.3605, 1.3605, the numbers are very clean. You get yourself 2 moles of hydrogen, and you get yourself 3 moles of carbon. So in the empirical formula is actually C3H2Cl. This is the empirical formula. So pretty standard little calculation. Then part B asks us to get the molar mass of the unknown substance. We're going to use the numbers from up here. So we're told that we dissolve 3.150 grams of the substance in some benzene. This is going to be our solvent, and get a freezing point of 1.12. Now the normal freezing point is 550, and the freezing point depression constant is 512. All that information will be needed. The first thing let's find out, remember, because our equation is delta T of freezing is equal to the constant, freezing constant, times the molality. In order to calculate the molar mass, we will need, molar mass, remember, is grams per mole, is grams per mole. So what we'll need to do is first find the molality, and then from molality we'll pull out the moles. So the first experiment, first piece of data we'll have to get is the temperature change. Remember, this is delta T, which will be between the regular and our solution freezing point. So we got 550 minus 112, which gets us 438. So this is actually 4.38 degrees C. So this is the first piece of information we'll use. And then we're going to apply this equation. We're going to rearrange it to solve for molality. So molality will actually be delta T of freezing over Kf. Delta T of freezing we've determined is 4.38. Kf is given to us as 5.12. If we calculate this correctly, we should get ourselves a fine value of 0.855. Now this is the molality again. This equals molality. The second piece of information. And now we recognize that molality is actually moles over kilograms of solvent. So to solve for moles, we got ourselves the molality times kilograms. Our molality is 0.855. Our kilograms will actually be 25 grams converted into kilograms. So into kilograms, that gives me 0.025 kilograms. And if you multiply those two numbers together, we get ourselves a value of 0.021387. This is how many moles we have. So we're almost there. This is how many moles. We were able to determine moles from the freezing point depression calculation. Finally, we want molar mass, and molar mass is simply mass divided by moles. Now, our mass will be the mass that we've reacted, which was 3.150. So we got 3.150 divided by the moles, which is 0.021387. Divide those two numbers into each other, and we get a fine value of 147 grams per mole. Usually your molar masses should be, in the range of 20 to 200, something like that. So that's about right. That sounds about right. 147 grams per mole. I did that very quickly. So analyze it. Make sure you understand the steps. This is really the same thing we did in our freezing point depression lab. And so just a little more practice for you. Let's go on to C, and then to D. So in C, we're asked to calculate the mole fraction of benzene in the solution above. Remember that the mole fraction, this is really a calculation of concentration. Mole fraction of benzene, and we can actually put C6H6, that is benzene, will be the moles of benzene, C6H6, divided by total moles. Now, the moles of benzene is given to us, we're given grams of benzene. We get 25 grams of C6H6, and we'll be able to convert that, just convert it to moles. A mole, and if you total up the molar mass of benzene, we should get ourselves 78.12 grams. So the moles of benzene is 0.32 moles of C6H6. We get that. We can do the same thing with our unknown. Now, we're not given the formula of the unknown, but we are given, we just determine its molar mass. So we know that we have ourselves 3.15 grams of the unknown. So we know a mole of the unknown. We've determined this from upstairs now, from part B. A mole of our unknown is actually 147 grams. So we can now find the moles here, which is 0.0214 moles. Now, to get the mole fraction is benzene over total, so we'll divide these two numbers, except down here we will have to put also some more moles of benzene. So it's the total. Mole fraction is the total moles on the bottom. And this, if you divide these numbers, we should get 3 sig figs. We should get ourselves 0.937. Now, mole fraction has no units, so 0.937 is actually the answer. It's a unitless number. Good? And now they're asking us to use this mole fraction to get the vapor pressure of benzene. So a quick little vapor pressure problem, not too bad. Vapor pressure of pure benzene is 150 at 35 degrees C. So we want to know the vapor pressure of the solution itself. And the equation is this. Vapor pressure at a certain temperature is equal to the mole fraction of your benzene, C6H6, times the original vapor pressure of that benzene, C6H6. So it's actually as simple as taking the original vapor pressure multiplying by the mole fraction. And that's exactly what we'll do. The mole fraction was determined to be 0.937, and the vapor pressure of benzene is given to us as 150. It's as simple as 150 times 0.937, which gives us 141 millimeters of mercury. So a nice problem that applies a few different concepts from this chapter 13. Actually, all the concepts that we've learned, one way or another, have been applied. So study this and come with questions, and we will see you at the test.